Here I want to quickly show you how we can solve two simultaneous equations with the matrix method. And I think this is a very elegant method which can be very easily applied. What we do need to do is a little bit of a revision of how we are working with matrices. Now, just as a sort of a revision, what is a matrix? A matrix is just simply some kind of notation how we can write these equations in a very nice and succinct form. And what we do is we just use the first equation, and instead of x and y, we just assume that we have these columns. So we assume that we've got column x and y. So we only write the factors. So for the first equation, this would be 3, because 3 is the factor of x, and 2 is the factor for y. And for the second equation, we would just simply write 2, because that is the factor in front of x, and -7 for y. And to indicate that this is a matrix, we put a bracket around it. And to make this equation complete, we would write x and y. These were our columns that we used. And we would also write the result matrix, which would be just simply the result, 19 and -4. So the way we need to read this matrix is basically 3 times x plus 2 times y equals 19. So that's our first equation. And for the second equation, we would read 2 times x minus 7 times y equals -4. So that is the notation how we would write these two simultaneous equations in matrix form. Now we need to revise how we find the determinant of a matrix. So that's the determinant. The determinant of a matrix. So let's say we have the matrix A, B, C, D. And the determinant of the matrix just simply would be we multiply A with D, A times D, minus B times C. B times C. So that would give us the determinant of a matrix. That's basically the number that this matrix actually carries inherently. Okay, now we've got really everything that we need to solve this equation. Let's just simply find the determinant of the matrix 3, 2, 2 and -7. Let's find this determinant. So that would be 3 times -7 minus 2 times 2. And we don't need a calculator for that. 3 times -7, that is -21, minus 4, and that would give us -25. We could also determine the determinant for, let's say, x, for factor x. So how do we do that? Well, what we do is we take our original matrix here. That's our original matrix, the xy matrix, and we substitute the x that we have. So I write this down again. 3, 2, 2 minus 7. And I substitute the x values that I indicate here with the result matrix. So that would be 19 and negative 4. So that is the substitution for the x values. And now I can calculate the determinant for this, because that would be 19 times negative 7 minus 2 times negative 4. So, and you see we've multiplied crosswise here. So negative 7 times 19, that gives us negative 133, minus 2 minus 4, that gives plus 8. So we would get negative 125 for this the x. We can do the same thing for the y, for the determinant of y. And here we just take the original matrix, so 3, 2, and 2, negative 7. And instead of the y values here, I just cancel them out and I replace them with the result matrix, with the result vector, I probably should say 19, negative 4. And I would get 3 times negative 4 minus 19 times 2. So that's this one here. And here I get, what do I get here? 3 times negative 4 is negative 12 minus 38. And that would give us negative 50. So that is the determinant for y. And now I can use this information to actually find x, because x is the determinant of x divided by the general determinant, and we've calculated them. So the determinant of x was negative 125. That is what we just calculated here. And the general determinant is negative 25. That's this one here. So negative 125 divided by 25, the negative sign cancels out, and the result would be 5. And we can do the same thing for y. So y, we would use the determinant of y divided by the general determinant. So that would be negative 50 divided by negative 25. Again, negative cancels out, and we have for the result y equals 2. Now, of course, we want to double check that this is correct. So we place the values into one of the equations. So we've got 3 times 5 for x equals 5 plus 2 times 2 for y equals 2. And what we've got is 15 plus 4, that's 19. And we should get 19 here as well. And we could do that for the equation number 2 as well, but it's pretty likely that we got the right value. So this is how you can solve two simultaneous equations with what is known as the matrix method. I hope this makes sense, and thank you very much for watching.